So in the last session, we have discussed about the types of the waves, that the wave can be a transverse wave or it can be a longitudinal wave. If the particle vibrating parallel to the direction of the wave, we call longitudinal, but if they are vibrating perpendicular to the direction of the wave, we call that as a transverse wave. And then we discussed different parameters related to the wave, crest, trough, the frequency of the transverse waves, and the wave equation. So this is the last point which we have discussed, the phase difference and the path difference, which we want to work out between the two waves. And we can study the properties of the wave by using a ripple tank. We can study the reflection, refraction, as well as diffraction. Okay, the new topic today, the learning objective, that you should be able to explain the term wavefront, coherence, path difference, superposition, interference, and phase. And there should be a relation between the phase difference and the path difference that we already discussed. And what is a standing wave? So what is the standing wave? A wave which is formed by combination of two or more waves traveling in opposite direction. Like example, one wave is moving towards the right hand side and the other wave is moving towards the left hand side. So when two waves are there which are moving in opposite direction, when these two waves combine with each other, as a result, what we will see, the combination of two or more waves traveling in opposite direction, this result in a formation of a standing wave, or we can also say stationary wave. And this stationary waves, it is formed by superposition of the two waves which are traveling in opposite direction, and as a result it might produce nodes and antinodes. What is a standing wave? The wave which does not change its position from one place to another. Like example, say a string is there, or we have a wire or a string which is fixed from both ends, and we disturb this wire from the center. So the moment we disturb from the center, what will happen? The two waves which are produced, they will travel in opposite direction, and as a result, when they travel in opposite direction, they will strike the end and they will bounce back. So when they bounce back, the two waves after striking a surface bounce back. As a result, when these two waves combine, this will give rise to a standing wave. And this standing wave, what it will have? It will have a pattern. The minimum pattern which it will have, like the maximum displacement refers to the node, and the maximum displacement refers to antinode, and the minimum displacement is refers to node. So region where the displacement is minimum, very small, that is node. So we have node here on the right hand side, we have node on the left hand side, and the distance between the node and antinode where the displacement is maximum, that is known as the antinode. So this wave which is produced by the combination of two or more waves which are traveling in opposite direction, or superposition of two waves traveling in opposite direction, this wave is known as standing wave. So the amplitude of the stationary wave or a standing wave vary with the position. At node it is 0. As you can see here, what is the meaning of amplitude? Amplitude refers to displacement from the mean position, and maximum displacement is called the amplitude. So the distance from the mean position for node, it is 0. So as you can see, it is 0 at the node, and all the particles between the two successive nodes have the same phase. what does it mean all the particles have same phase? Because when the standing wave is produced, so maybe the particles, all the particles are there at the side of the crest, or all the particle will be there at the side of trough. So when these particles are moving, what did which direction they try to move? They try to move downward or towards the mean position. That's why we say all the particles which are there between the nodes, they have the same phase, like they're vibrating in the same manner. So those particles, if the wave is at the crest, then all the particles are tend to move downward towards the mean position. But if it is at the trough, then all the particles tend to move upward or towards the mean position. So all the particles between the two successive nodes have the same phase. And the particle either side of node or antinode are 180 out of phase. So what does it mean? Like example, if a pattern is produced in this manner, say a standing wave is produced by a combination of two or more waves. So example, this is a node. So the particles which are on opposite side, either side of a node or antinode, they are 180 out of phase. What does it mean? It means, like example, when we take the particles on the left hand side of this node and we take the particle on the right hand side. So what happened? The particles which are on the left hand side, they tend to move towards the mean position downward. Whereas particles on the right hand side, which direction they tend to move? They tend to move upward. So as you can see, one particle, a group of particles tend to move downward, another group or particles tend to move upward. So it shows that the particles on either side of the node are 180 out of phase. Then does not transfer energy, but there is energy in the wave. So basically what happened, because the wave is confined within the region, this wave cannot travel from one place to another. It is limited to one place, so it does not transfer energy any other point. The energy is confined within the region, and all the particles have the same frequency except at node. At node, because the particle amplitude is zero, so at node the particles are not moving at all. So except the node, all the particles complete same number of cycles or vibration per second. Is it clear, the concept of the standing wave? When two waves are traveling in opposite direction, what they give rise to? They give rise to a standing wave. And it basically produces a pattern of the wave. The region where the particles are completely cancel out each other, it will form a node, and the region where the particle increase the effect of each other, that is antinode. Any doubt in this part, the standing wave? So as you can see here, the node which is marked by letter N here never moves, and these occur where the two waves interfere destructively. What is the meaning of destructive interference? The term destructive interference means like two waves try to cancel out the effect of each other. The point, example, we have two waves which are traveling in opposite direction. Say the red one is representing one wave which is moving towards the right hand side, and the black is representing another wave which is moving towards the left hand side. So you can see these two waves here, the crest of one wave joined with the trough of the other. So when crest of the one wave join with the trough of the other, as a result, what they do, because they are 180 out of phase, and if they are 180 out of phase, the particles are vibrating in different manners. So as a result, what they do, they try to cancel out the effect of each other. And when they cancel out the effect of each other, we will observe a destructive interference. So at this point where the particles completely cancel out each other, what we'll observe, a node. Because the two waves, the crest of the one wave join with the trough of the other, so the two waves completely cancel out the effect of each other and we'll get a node. But if the two waves are in phase, when they at certain point when they are in phase, as they combine with each other, as a result, what happens, they will increase the effect of each other. Like this is one wave and this one is a second. So as a result, what you can see, the crest of the one wave join with the crest of the other. The two waves are traveling in opposite direction. This time also they will interfere. The two waves will have interference or combination, but because they are traveling in opposite direction, so they will give rise to a standing wave, or superposition we also call. And as a result of this superposition, because crest of the one wave join with the crest of the other, so as a result, the resultant wave will have a much higher amplitude. So when the resultant wave is produced, so this will have a much higher amplitude, and as a result, what it will produce, it will produce a antinode. So antinode is refers to the region of the particles which are having a maximum amplitude, and where node is refers to a region of the particle which are having the minimum amplitude, as the two waves at this point cancel out each other. So antinode, as you can see, it is marked with letter A here. So antinode which is marked A are the points of the maximum displacement, and they occur when two original waves interfere constructively. So constructive interference refers to the two waves increase the effect of each other, whereas destructive interference refers to the two waves reduce the effect of each other. Is it clear, like how the two waves which are traveling in opposite direction leads to formation of a standing wave? Now, standing wave can be produced in a pipe, or standing wave can be produced in a string. So you have to learn the two cases. The standing wave can produce in a string or a wire, and the standing wave can be produced in a pipe. And then pipe can be divided into two categories. It can be an open pipe or it can be a closed pipe. So what happens, how the standing wave is produced in a string or a wire? Basically, if you have a wire or a string which is fixed between the two ends, and you disturb this wire from the center. So this is a string or a wire which is fixed between the two ends, and you disturb from the center. When you disturb from the center, so it can produce different patterns. When you exactly disturb from the center, what happens? It will produce the disturbance which you produce here will travel in first opposite direction, but as they strike the ends, they will bounce back. So when you disturb, the waves are produced at the center which travel in opposite direction. They strike, and the moment they strike, they will bounce back. And when they bounce back, these two waves which are traveling in opposite direction, as you can see, this wave on the left hand side, far left, and the wave on the far right hand side, because these disturbances are already transferred, it will strike the two both ends and bounce back. So when two waves which are traveling in opposite direction, they combine with each other, as a result it will produce a pattern. And what kind of pattern it produce? It will produce always node and antinode. So near the end it will always be nodes, means the particles have zero vibration as they are 180 out of phase in terms of vibration. So near the end it will always be node, and at the center, if it is vibrating in one loop, so if it is vibrating in one loop, at the center we will have antinode. So this will be node, this will be node, this is also node, and this one is antinode. But it's not like only this pattern can be produced, or so, and either this part of the wave, either it will be in the side of the crest or it will be side of the trough. So you should be able to explain how standing wave is produced. So what should be your answer if a question is how standing wave is produced? Whenever two waves are traveling in opposite direction, you have to mention this term, traveling in opposite direction, because if they are traveling in the same direction, they cannot give rise to a standing wave. So the two waves traveling in opposite direction give combine with each other, so create or produce a region where they interfere or superimpose with each other. The region where maximum amplitude or constructively they interfere, we call that as antinode, and the region where destructive interference occur, we call that as node. This is when it is vibrating in one loop, but it is not necessary that it is vibrating. It can vibrate in different loops. Like example, if a wave or a string or a wire is there which is attached between the two ends, and we disturb, so it might produce two loops, or it might produce three loops. So the number of the loops can change depending on the position where we disturb the string. But if it is exactly disturbed at the center, this will give rise to a standing wave with only one loop, and we call that as first harmonics. When it is vibrating in one loop, that is known as first harmonic, like first vibration. Then this is second harmonic, this is third harmonic. Is it clear the concept how the wave is standing wave is produced in a string? Any doubt till this point? Then how standing wave can be produced in a pipe? And a pipe can be an open pipe or it can be a closed pipe. What does it mean closed pipe? Closed pipe means the pipe which is closed from one end. That's called closed pipe. And the pipe which is open from both ends, it's known as the open pipe. So standing wave can produce, the standing wave can produce in a closed pipe. How standing wave is produced in a closed pipe? Basically, when we produce a wave, so the wave will travel and it bounce back. So two waves will be there. One is the wave which we produce and the one is the wave which bounce back. So two waves which are traveling in opposite direction, as a result, what they will produce a standing wave. And when it produces a standing wave, always remember that near the open end, because when the particles are vibrating, like if I say normally a sound wave is produced, like a standing sound wave is produced in a closed pipe or open pipe. So what happened in sound wave, like example, this air column. So this pipe is filled with air. When we produce the disturbance, when we produce the sound, we cause a particle to vibrate. Some particle vibrate faster, some particle vibrate slower. But what happened? It transfer the vibration. So first, as it transfer the vibration is transferred towards the right hand side, and then it bounce back. So as the two waves now traveling in opposite direction, what it create standing wave. And in this standing wave, the region where we have open end, that region the particles will vibrate at a higher amplitude. But as we move more towards the mean position, like the close side, the vibration of the particle decreases. So as the vibration of the particle reduces or decreases, eventually there will be no vibration at the close end. So when we draw the pattern, because we don't have to draw the particles, we just have to mention a region. So when we draw a pattern, a region where the particles have the maximum amplitude, so we call this region as antinode, and the region where the particles have the minimum amplitude, node. So when we complete this wave, so we draw node of maximum amplitude, antinode of maximum amplitude, and node of minimum amplitude, and then we complete this. So only half of the loop is produced here, and this is a minimum loop, number of the loop which can be created in a closed pipe. That's why, or it is the first kind of vibration, so we also call that as fundamental, or also known as first harmonic. So what is the meaning of first harmonic? First harmonic means the pattern it produces a minimum, the smallest pattern of the wave it produces in terms of vibration. So we call that as first harmonic. But what about the open pipe? What happened in open pipe? The two waves which are traveling in opposite direction. So as a result, when they travel in opposite direction, they will also combine. And node, as we know, always at the open end we'll have antinode. So this will be antinode, this will be antinode. So between node and between two antinodes, there will be a node. So when we produce a pattern, antinode means maximum amplitude and node means minimum amplitude. So when we combine, this is a minimum way the vibration can produce. So what we call this, we call that as first harmonic. So when two waves which are traveling in opposite direction combine, they result in a formation of a standing wave. So standing wave can be produced in a string, standing wave can be produced in a pipe as well. And in case of pipe, a pipe can be an open pipe or it can be a closed pipe. Open pipe means which is open from both ends, whereas closed pipe, means it is closed from one end. Then you have to learn the equation which we can use. So it's not necessary you memorize, you can understand this equation, you can also form this equation. How this equation can be formed, like example, if we produce a standing wave in a string, so and it is vibrating in one loop, this is one loop, this one is two loops, and this one is 3 loops. So region where the particles have the minimum amplitude, that is node, and the maximum amplitude is antinode. Example, the length of the string is L. So if length of the string is L, what is this distance in terms of wavelength? How to work out the distance in terms of wavelength? Because when we have 3 successive nodes, node, node and node. So when we have 3 successive nodes, that distance is known as the wavelength, which is denoted by lambda. So 3 successive nodes denoted by lambda, but now when it is vibrating in one loop, it is 2 successive nodes. So if 3 successive nodes, it is lambda. So between the 2 nodes, it will be lambda by 2. So we can say this distance between the 2 successive nodes, it is lambda by 2. And it is vibrating in one loop, so we can say lambda 1 by 2. Because the wavelength will change as the number of the loops are changing, the wavelength will also change. So in this example, in this case, we can say the wavelength divided by 2 is equal the distance between 2 successive nodes, that is lambda 1 by 2. So we can say L, so we can say L is equals to lambda 1 by 2, means the length of this string is half of the wavelength. Or what is the wavelength when it is vibrating in one loop? So wavelength when it is vibrating in one loop, that is 2L. So sometime they give you the length of the string and they mention it is vibrating in one loop. So you have to work out the wavelength. So the wavelength whenever a string is vibrating in one loop, it is always twice of the length of string. Then if you want to find a frequency when it is vibrating in one loop, so we have the formula V is equals to F lambda. That's the wave equation. So V is the speed of the wave in a string. F is a frequency which, so V is equals to F1 lambda 1. Why I am saying F1? Because the frequency will change as the number of the loops are changing as well as the wavelength. So F1 means when it is vibrating in one loop and lambda 1 means it's a wavelength of one loop when it is vibrating in one loop. So V1 is equals to F1 lambda 1. And we know lambda 1 is 2L. So in place of lambda 1, we can write 2L. Or this 2L is multiplied, other side it will be divided. So V divided by 2L is equals to F1. So V divided by 2L is equals to F1. Or here why they write F0? F0 also means fundamental frequency. So you can also say F1, the frequency when it is vibrating in one loop is given by a formula V divided by 2L. Is it clear the part how to work out the frequency or how to calculate a frequency and the wavelength when the string is vibrating in one loop? Any doubt till this point? What if it is vibrating in two loops? For example, if a string is vibrating in two loops, which is when it is vibrating in two loops, we can also say first over 2. So we want to drive a formula, as we know first what is the formula for the what is the formula for wavelength? As you can see, this is node, node, and node. So distance between the three successive nodes, that is equals to lambda. But we say lambda 2. Why we say lambda 2? Because it will not be same as the when it was vibrating in one loop, the wavelength was different. Wavelength was greater, but now it is vibrating in two loops, so wavelength is shorter. So we can say L is equals to lambda 2, like when if it is vibrating in two loop, the wavelength is always equals to length of the string. And we have the formula V is equals to F lambda. So F2 and lambda 2. Why I'm writing F2 and lambda 2? Because it will have a different frequency when it is vibrating in two loops. And in place of lambda 2, if I write L, so I can say V is equals to F2. In place of lambda 2, I can write 2 L only. Or V is equals to F2 divided V is or F2, the frequency is equals to V divided by L. So why here this F1 is written, it means it is the first overtone or when it is vibrating after first harmonic. That's why they would, but better you use F2 here so you will not be confused with the number of the loop. But in this part where what I explain is 2 is representing the number of loops. And we already work out when it was vibrating in one loop. So when it was vibrating in one loop, V over 2L was F1. So V over 2L was F1. So we can say V over L is equals to 2F1. This is when it was vibrating in one loop. So V over L is 2F according to one loop, and V over L is equals to F2. So when we compare the two equations, we can say F2 is equals to 2F1. So what does it mean? It means, like example, when it was vibrating in one loop, say the frequency of the vibration was 50 Hertz. But now it is vibrating in two loops. So the frequency of the vibration will be twice, like it will be 2F1. So it will be 2 into 50, and 2 into 50, that will make 100. So it means as the number of the loops increases, the frequency of the vibration will also increase. So this is what we'll observe in a string or a wire. As the number of the loops increase, the frequency will increase, wavelength will decrease. But the product of the frequency and the wavelength remains same. That's why the speed will be same. So speed at which the wave is traveling in the string, like example, if I say the wave was traveling at a speed of 400 example meter per second. So here also it will be 400 within the region 400. But what happened? What is the difference here? When it is for one loop, the wavelength is greater, but the frequency is shorter. When it is vibrating in two loops, the wavelength decreases and the frequency will increase. But the product of frequency and wavelength remains same. That's why the speed of the wave will be same in all of this. And if it is vibrating in three loops, so when it is vibrating in three loops, how we can work out? So this is a one complete wave. This one is lambda by 2, lambda by 2, lambda by 2. Like, and it is three loops, so I'm saying 3 lambda by 2. 3 is not like multiple, it's just representing the number of the loops. So the total, it will be lambda 3 by 2 plus lambda 3 by 2 plus lambda 3 by 2. When we simplify, it will be 3 lambda 3 by 2. So means the length is equals to 3 lambda 3 by 2, and when we find a lambda wavelength, so 2 will be multiplied and 3 will be divided, so it will be 2L by 3 is equals to lambda 3. And we have the formula V is equals to F lambda, but because it is in three loops, so frequency third and wavelength third, or V is equals to F3, lambda 3 is equals to 2L by 3, so in place of lambda 3 I can write 2L by 3. This 3 is divided, other side it will be multiplied, and this 2 is divided, other side 2 is multiplied, 2L, other side it will be divided. And what is V over 2L? V over 2L is actually equal to F naught or F1. So we can say 3F1 is equals to F3. So when it is vibrating in three loops, like example, if it was vibrating in one loop, if the frequency is 20 Hertz, the vibrating in three loops, the frequency of the third three loops will be 3 times the original first harmonic. So it will be 3 times the 50, it will be equal to 150 Hertz. So as the number of the loops of a standing wave increases, the frequency will also increase. Is it clear, this part? So when we journalize this formula, when we journalize or we write a journal formula like relating the frequency, so we can say Fn is equals to Nf1. That is where n is equals to the number of the loops. And the second formula which relate the frequency and length. So V over 2L times N is equals to Fn. So N is now again the number of the loop, Nf is Fn is a frequency of that nth loop, V is the speed at which the wave travel, and L is the length. Then this is one formula, like we have this formula that speed of the wave is given by a formula. So we have one of the formula which shows that V over 2L is equals to NF N V over 2L N times V over 2L is equals to Fn. And there is also another formula for speed of the wave in a string, that is V is equals to under root T divided by mu. What is T? T refers to tension, how much force is there in the wire, and mu refers to mass per unit length, like how much mass is there in a unit length for a string or a wire. So when we compare the two equations, if we compare, like simplify for V, so V is equals to Fn into 2L divided by N. And here V is equals to under root T divided by mu. So when we compare the two equations, we can say Fn into 2L divided by N is equals to under root T divided by mu. Further simplifying the equation, we can say Fn is equals to N under root T divided by mu 2L. So this is also a formula to calculate a frequency. And what it shows a relation between a frequency. It shows frequency of the wave in a string is directly proportional to under root of the tension. Like if we apply more tension on the string, the frequency will be higher. That is how the guitarist, you will find there are knobs to tighten the string of a guitar. So what is the purpose of that? So by changing a tension, they can change the frequency which is produced by the guitar. Same way, what is mu? Mu is the mass per unit length. So it is inversely proportional to mass per unit length. As you can see, even in a guitar, the different strings have different thickness. So they have different mass per unit length. And it is directly inversely proportional to length of the string as well. So guitarists, they use their fingertips to change the length of a wire which is vibrating, like they place their fingertips at the position where they want the wire, like the length of a wire used to produce a sound. So by changing the length, they can produce different frequency from the same string. So this formula relate the frequency of a wave in a string by tension, mass per unit length, and the length of a string. Is it clear, this part?